functions. Sinusoidal does not mean sine, okay? It means a wave graph. Lots of people think when I say graph this sinusoidal function, they're like, oh, it's a sine graph, I have to graph sine. That's not true. It results in a wave. Like just like a parabola, we know what the shape of a parabola is. We know what a sinusoidal is. It's a wave. And we're going to learn how to graph that.
We don't have that page.
It's the very front cover, everybody. It's the front cover. Ha ha.
Looking at my expectations.
Okay. All right. Sorry. Normally I write it, you write on the titles of the lessons, but this is the cover of the book. So this is a mistake that I see quite often is when I ask you to graph a sinusoidal function, people default to sine just because it has sine in the name, but that's not what it is. Like if I say graph a linear, you know you're doing a straight line. If you're graphing a parabola, you know that that's the curved up-down shape. Sinusoidal wave. So just a fancy name for what we're about to do. Okay, now I'm on page 3. I'm on the very first lesson. Okay. We are going to graph the unit circle. Yeah. All right. Everybody good with that? Today we're going to be looking at sine and cosine functions. So we know that sine is the y coordinate. Oh, I'm running out of room. Y coordinate, and cosine is the x, right? Everybody knows that from their unit circle? You all get a tattoo of it? Perfect. Okay. Amplitude. Have you guys done any physics?
Yeah, that's the
It is part of the wave. Okay, what part of the wave is it?
the height. Yeah, the height.
From?
From the hold on.
0 to either peak.
Wait, it's
You're on the next one. Maybe you're not on the next one.
from the peak to the middle, or the trough to the middle. I don't know what the middle line is called though.
Okay, good. So if you've done physics, this is not going to be a shocker to you. It's the height or the depth from the median. What do you guys call it, a trough, like the bottom?
Yeah.
Okay. All right. Okay. Period.
That's how long a wave takes to cycle.
Okay. So none of this makes sense until we actually graph it. And that's okay. Okay, great. So period, when we talk about the period on the unit circle, what's the angle measurement to get back to the starting point? If my starting point is at 0.
360.
360. Okay, everybody know that? So the period on just the regular unit circle and what we're going to do right now, the period is 360 degrees. It's pretty exciting stuff. I know you're super excited. So we're going to graph this. We're going to graph the sine. So we're looking at that y coordinate on the unit circle. We're going to be looking at that by angles. All right, here we go. We're going to fill in this table from your knowledge of the unit circle, everybody. We're going to start at 0 and we're going to go positive first. We're going to go positive because that's who we are. So we're looking at sine. So sine is the y coordinate on our unit circle. So at 0 radians, what is y? The y value there.
0.
Are you sure? Okay, good jump, everybody. At pi over 2,
1.
1. At pi, 0. At 3 pi over 2, -1. And at 2 pi?
0.
Also 0. Proud of you guys. Okay, now we're going to go backwards. So if we start here and we go negative pi over 2, -1. Now we're at negative pi.
0.
0. Negative 3 pi over 2. 1. And negative 2 pi?
0.
Oh, so proud of you guys. So there's your knowledge of the unit circle. That's pretty exciting. Proud of you. Now let's graph it. So we're not graphing the x and y coordinates from the unit circle. We're graphing angle and sine of that angle. Just happens to be the y coordinate of that. So this is sine of the angle. So our x values are the angles and our y values in this case are sine. But that's all given there. All right. Let's graph. I gotta go to 2 pi. I'm gonna go halfway. So that's pi. This would be pi over 2. This would be 3 pi over 2. And you're like, Skyline, why are there not increments on this graph already? Why is this just a cross in the middle of the page? I find it easier just to kind of graph it like this first. I get a little bit comfortable with it. And there will be ones with grids on them. But for what we're doing right now, you don't really need that. Okay, that's exciting. On my y, what is the maximum y value I got going on here? In the y column here. 1. Okay, so that's just putting my increments on. I haven't really graphed anything yet. Okay, so if you have taken physics before, when you're graphing a sinusoidal or a wave, what do you need to connect the points with? Smooth curve. It's a gentle curve. It is not harsh absolute lines. It's a smooth curve, kind of like your parabola, but bigger. All right, let's see what we got. I better use an erasable pen because I don't want to screw anything up. All right, so I'm going to start at 0, 0. That's exciting. Pi over 2 is 1. Pi is 0. 3 pi over 2 is -1. And 2 pi is back to 0. Guys, I don't care what order you graph them in, but what I've noticed sometimes is when you guys don't do them in an order, you connect them in funky orders. And that's bad, oh bad. Negative pi over 2 is -1. 0, 1, 0. I'm just gonna talk for 1 second. You have been given a restricted domain. So what that means for graphing is that there's no arrows on this, okay? There's no arrows on this graph because it's restricted. It says go from -2 pi to +2 pi. It's giving you a restricted domain. All I want is this. If you put arrows on it, that's a half mark deduction because you have graphed outside the given domain. Does that make sense to everybody? All right, connect them with a smooth curve like you're connecting parabolas. Okay, that's not too bad for me. I would deduct a half mark off myself. Anybody know where I would deduct it? Yeah? Where? Where? You don't know? I deducted here. Because it should crest at this point. This point is not 1. This point is not 1. Still not perfect, but definitely better. Okay, how do you like that? Wave function? Proud of you guys. And all that was the unit circle. We just put it two-dimensional on a graph looking at angles versus sine. That's all we've done. That's exciting. Okay. Can you guys tell me what the amplitude of this graph is? And the amplitude is going to be an absolute value. No, it's going to be an absolute value. It would never be -1. It would never be -2. It would never be -14. So what's the amplitude on this guy? Remember that you're not going from the bottom to the top, you're going from the middle. Hey, where's the median?
Y equals 0.
Y equals 0. So what we know is that the middle point of this graph is the x-axis, right? If we said our amplitude is 1, we're measuring from the x-axis up, right? So from here to here has a height of 1. So that's my amplitude. So therefore, this has to be the middle. We're baby stepping it, ladies and gentlemen. We are baby stepping this because we're going to start shifting this graph around, and your median won't always be at y equals 0. All right, let's talk about your period. Pick a starting point. Pick any starting point, ladies and gentlemen. 0. Okay, so these two are related to the range, and then the period is related to the domain. All right, so Gazzy was kind enough to pick 0 on the domain. So what y value is it when x is 0? Y is 0. Where do we hit 0 again? Pi. Does this show the entire graph between 0 and pi? No is the correct answer. What does it show us? It shows us the top part of the graph, but it doesn't show us the lower part of the graph. So from here, let me get a highlighter. From here to here would be my period, because this shows, hey, I've hit a maximum, and then I've hit a minimum, and I'm back to my starting point of 0. So how far have I traveled, as you're all frantically getting your highlighters out? A full rotation, but remember it's related to the domain. So I started at 0, and I ended at 2 pi. 1 cycle, give it to me as a radian.
2 pi.
2 pi. That's a bad pi symbol, but we'll go with it. Mm-hmm. Yeah. Okay, so math is pre-cal is kind of like the pure math, right? We're looking at it in isolation. I'm teaching you kind of the mechanics of it. Physics is applied mathematics, right? So they're showing you how different things will respond, and some of them will respond in wave patterns. So you're measuring like sound waves and things like that using the sound pattern. So you're doing the applied of the pure. So why don't we teach it to you in the correct order? That I cannot tell you, but there's some stuff you need to know. Okay, let's do cosine. Yay, cosine. All right, so our y value here is actually, how is this confusing? We're just putting it on a graph. I know, it is confusing, no question. None of the math we've done is technically hard, but there's so much to remember. My advice to you guys for studying for math is I would make a cheat sheet. Can't use it on the test, but you can organize your thoughts. What are the critical pieces? And if you do that all the way along in this course, you're gonna have, when it comes to exam time, you're gonna have 11 study sheets that are like the essence of what you need to know throughout the course. So you can look at those when you get to your provincial exam. Don't wait till the end to do them. Do them for every test. That would be something I would recommend to you guys. I think you're gonna need a single piece of paper for each of them if you can boil it down to that. Study cards, I don't know. I lose those. I'd much rather have a single piece of paper, but it's whatever works for your brain. Okay, let's start again. I always like to start with my positives. So at zero, what is my x value at 0? 1. At pi over 2. At pi. 3 pi over 2? 2 pi? 1. Negative pi over 2, so we're back here. 0. Negative pi. Negative 1. Negative 3 pi over 2. 0. Negative 2 pi. 1. Yeah. All right, let's, did you guys notice a pattern in the table? Maximum, median, minimum, median, maximum. We're gonna start talking this language really soon, and you're gonna be so excited. So, and as you cycle through it, there's positive, 0, negative, 0, positive, 0, negative, 0, positive. Like it's gonna cycle through it. There is a pattern here. And it's like the symmetry in parabolas. Like there's patterns and they work. But if you don't see them right away, that's okay too. I've had a lot more time to linger with this stuff than you'd have, so. You guys graphing this? All right. Are you guys graphed or no? All right. So ladies and gentlemen, you've just graphed a sine and a cosine graph. Let's look at these. This one's your sine. Your bottom one, I just folded my page in half and put the sine on here. And here's your cosine graph. What do we know the amplitude of the cosine graph is? 1. What do we know the median is? 0. Same thing, right? What's the period on cosine? 2 pi. But do the graphs look different? Yeah. If I'm on a sine graph, where do I start? I start at 0, 0, right? I start at that median. If I'm a cosine graph, where do I start? I start at the top. I start at a maximum. And I'm going to use this language, so you're going to just have to get used to it. So median, maximum, minimum, right? Graphed here. So what I need you to know is a sine graph is always going to start at a median, head it to a maximum. So median to a max, unless there's a reflection. Cosine graphs will always start at a max. And when I say start, you're like, Sky, and there's a wave. Where do I start? I'm talking at 0, 0. Like I'm talking at when x is 0. Now we're going to do some shifts on this too, and then that's going to blow this out of the water. But I promise if you follow the given steps, it'll work, question mark. Okay. All right, let's fill in this chart. We know things. What's the amplitude on the sine and cosine graph? You just told me. 1 and 1. What's the period? What's the period? We did it on the 2 pi. And that's the same for both of them. What is the domain of, okay, let's say there wasn't a restricted one. What would be the domain if I didn't restrict it?
Just all possible numbers.
Mm-hmm. So how would I say that? X is an element of all reals. So we could say it like that. What's another way we could say it?
Negative infinity to positive infinity.
Yep. And that would be the same for both of them. In this case, though, what would I be replacing my x with?
Negative 2 pi. Theta.
Theta. Just x wasn't defined. So just make note of that, depending, like we're talking generality, so x is fine here. But just make sure you're paying attention to the variable used in the given equation. Okay, range. On both these graphs, what's the range? What's the lowest you go? Negative 1. Square bracket around that to positive 1. That's the same for both of them. Zeros of the function. We're going to write a general solution for this. Okay, we always start with our first positive 0. This is a sine graph. Where's my first positive 0? And you guys know what a 0 of the function is? It's your x-intercept, right? 0, 0 would be my first, but you wouldn't be wrong if you put pi. What's the distance between these two? Start at 0, I go to pi. How far have I gone? Pi. I'm at pi. My next one is at 2 pi. How far did I go? Another pi. So would you guys agree that every pi we're getting an x-intercept? Okay, we're going to write a general solution for that. Now, Prince, if you wanted to put the pi symbol here instead of a 0, you could have done that. You could actually do this. But that's just weird. I don't like that. I like something in front of it. It's just who I am. But you would not be wrong if you just did that. Okay, look at that. You made a general solution for zeros of the function. X-intercepts, right? So let's look at cosine. Where is our first positive x-intercept? Pi over 2. Where's my next one?
3 pi over 2.
How far of a distance is that? Pi. Same general solution, but my starting point is different. So the x-intercepts, we have many. With the y-intercepts, we only have one of them. So on the sine graph, where is my first x-intercept, or y-intercept? 0, 0. So we are at y equals 0. When we look at the cosine graph, where do we cross the y-axis? 1. Asymptotes. Oh, fun. Any asymptotes on these graphs?
What's that say the same?
What are asymptotes?
There's like a line you can't touch, right?
It's a line you can't touch.
There's none of that here, right?
None of that. This is foreshadowing. I love it. Oh, no.
I hate asymptotes.
Okay, so here's the thing, ladies and gentlemen. Your basic, what we just graphed, was your basic sine and cosine graph. So do you guys remember when you went into grade 11, you learned how to graph your basic parabola, y equals x squared, right? And then we did a whole bunch of junk to the x squared. We shifted it, we stretched it, we reflected it. We're going to do the exact same thing with these cosine graphs. So where do sine graphs start? Yep, they start at their median. Sine always starts at a median. You guys can't read what I'm writing. You know what? I'm going to get rid of the word always, because as soon as we do a reflection on it, that's going to screw that up. And a cosine graph starts at a max. Always is like it's a strong word. Okay, how do we feel about those? Terrible? Okay? Nobody's cried yet? I'm going to call it a win. Okay, I'm flipping the page. All right, transforming amplitude. Amplitude. So remember that amplitude is related to the range. What variable is associated with that? Y. All right. As soon as you times your y values by a, you are stretching it. This should not be a surprise because you just finished chapter 1. Chapter 1 was all about transformations. They all apply here. So if a is less than 0, the graph is also reflected. Any negative value, but you know this from your transformation unit. This will not be new, but we're actually applying it to a specific function this time. Transformations affect sinusoidal functions. Vertical stretch by a factor of a. Vertical stretch changes the amplitude of the graph. So we are taking the graph and we are either stretching it or we are squishing it. We're doing one of those two things. Okay, let's graph y equals sine x. You're going to need some other colors for this, ladies and gentlemen. You're going to need some colors. Do what you will with that information. This is. Okay. Did I leave myself enough room? I think I did. Okay. Can you graph these from your knowledge of the unit circle, not looking at the table prior? Woo. Where do sine graphs start? Median. So there's no shift up or down, so our median is still at 0. We know when the angle is 0, y is also 0. What color am I going to make this graph? I'm going to make this one red. Nope, I'm going to make this one black. I don't even really need to remember the unit circle as long as I have a hot, sweet clue what happened before that. I know that my graph started a median and they go to a max, and then I can just follow the pattern. Every 90 degrees, something's happening. So start at 0, I head to a max, I have to hit the median on the way back, then I go to a minimum, have to hit the median on the way back, head to a max. So even though normally I've only graphed to 2 pi, I can keep going because I can just follow that pattern. Now this graph does not have a restricted domain on it. So what do I need? What do I need, ladies and gentlemen? Arrows. FYI, your sine function, the arrows need to be pointing in the correct direction. So if I stopped my graph here, and I was going to put my arrow on it, my arrow has to point down. Does that make sense to everybody? It has to point in the direction it's going. If you say, hey, my arrow's continuing that way, you are now outside your domain, you're out of your range. So that's bad, oh bad. Your arrow has to follow the path in which your data is going to travel. Pardon? I just was showing you, because like the last one, I hit a median here. So once I hit the median, where am I going? I was at a max, I hit the median, where am I going now in the pattern? No, I was at a max, a minimum. So this one was just pointing in the downward direction, which is correct. Okay. Do you guys want to do a table of values, or do you want to do just looking at it? How does that make you feel? A little uncomfortable? Once I get the table of values done, you're not going to want it. Okay. That's supposed to be a theta. That was looking a little sketchy. 0, pi over 2, pi, 3 pi over 2, 2 pi. And we know that sine x is 0, 1, 0, negative 1, 0. Everybody good with that? Hey, Mr. Parody. I'm recording a lesson. Would you like to be part of it? No? It's not going well? No. It's going great. So our next graph, we're doing, sorry, I circled up there, 3 sine x. 3 sine x. So what am I doing to the y values? What am I doing to the y values here, folks? Huh? Multiply by 3. So we're multiplying by 3. How does that make you feel? Not terrible, hopefully? All right. So we're going to use our table of values here. At 0, all I'm doing is taking the value of sine x and I'm timesing it by 3. What's 0 times 3, everybody?
0.
Brilliant. What's 1 times 3? 0, -3, 0. I think confidently I probably could have done that off the graph. I say that with some confidence. So I'm going to graph this point. This point doesn't change. My pi over 2 now goes up to 3. My 0 doesn't change. This one goes down to -3. My 0 doesn't change. My maximum goes up to +3, and this guy doesn't change. What should you be doing when you have more than one graph on a coordinate plane? Labeling them. It's showing up so much nicer on the screen than it is on my actual paper. Can we do the 0.5x in our heads, or do we need a table of values? We can probably do it in our heads. So 0, 0 stays the same. 1 now gets squished to a half. This gets squished to a -1/2. +1/2. 0. Okay, you guys can't tell the difference between my colors, but I swear this one is green. I don't know if my bright blue will show up, but we're gonna try it. How do we feel about -2x? Do we need a table of values for that? What does the negative tell us in front of the 2? I've got a reflection. I know that that's what is going to result in, like it's going to result in a reflection, but really what that means is I'm just timesing by the -1. In this case, I'm actually timesing by -2. So I'm going to have a vertical stretch, but I'm going to also have a reflection. So what happens to the maximums? What do they become now? They were maximums. I've reflected them. They now become minimums. Does that make sense? They go from a max reflected, they're a minimum. So if I have, I'm just going to do a table of values just for funsies. So notice I haven't changed my thetas at all. They're the same. So this is going to be -2 sine theta. So 0, pi over 2, pi, 3 pi over 2, and 2 pi.
Maybe sine x.
Oh, sorry, yeah, sine x. So this is still going to be 0. This one was 1. Now 1 times -2 is -2. This is still 0. This one's going to become a +2. So it was a negative, now it's positive. So this min turns into a max. And this will stay at 0. So we're going to have 0, 0. Oh my goodness, I'm getting a really... pi over 2 is going to be down here. Pi. 3 pi over 2 is going to be up here. That goes there. This goes down there. Okay, that's a really messy graph. So that A value, the thing in front of the trig ratio, is going to be the thing that messes with your amplitude. That's going to do the vertical stretch. And just in sinusoidal functions, vertical stretch and amplitude, like that's going to be the thing that changes. And the transformations we did in chapter 1, they're right here. We're just doing them on a very specific function. They're still graphing, people. Okay. All right, so this is kind of a handy little formula. If you're looking for the amplitude, and remember that amplitude, no, I'm not going to put that. If it's a negative, you're going to have that reflection in it. You're going to take your maximum, your minimum, subtract them, and divide by 2. So let's do that with the red graph, the 3x sign. What's the max?
4.
What? What's the max?
Maximum is 2.
How about 3?
For the red one?
For my red one. So we're doing it for 3 sine x. So the maximum is 3. We are minusing the minimum, which is a negative 3. And we're dividing it by 2. So the amplitude is going to be 6 divided by 2, which the amplitude is 3. So it's handy. Most of you can look at a graph and see it, but sometimes when we get those fractions in there and I'm not sure what to do, I just want to cry a little. But what else do you notice is that this 3 is already present here. I didn't need to figure it out. This is the amplitude. That is the amplitude. It is given in the equation. The amplitude, there's nothing you have to calculate. The only time you calculate amplitude is if I gave you a graph and said, hey, create the equation for it. Which, guess what? I will do that to you.
So if I have like run equations like this, and I'll just look at what has the greatest values, and I'll find out how
Say again. Okay. All right. Flipping the page. Okay. Here we go. Now we're going to mess with the period. And really all we're doing is we're doing a horizontal stretch or a horizontal compression. We are either stretching it out long ways or we are squishing it together. So we're going to do these on the cosine graph. So cos and sine graphs have 2 pi. In the graph y equals sine bx, the b causes the horizontal stretch. Okay. Are we ready for this? No? We're going to hope for the best at this point? Okay. All right. Can you guys go ahead and graph cos x? Just do the basic one. Oh, and I guess, okay, maybe stop for a sec. Stop for a second. Just stop. What do we know about x's when we're doing anything with the x values? Like when we did transformations. Go back to when we were doing the horizontal stretch. If this has a stretch of 4, what are we multiplying the x's by?
4.
1 over 4.
very hard from the get-go.
Did I?
Yeah,
Really? So terrible?
it is terrible.
I'm sorry. And this guy, what are we gonna do?
Multiply by a factor of 2.
Okay, somebody gasps. That's not every day that this happens, that we get a gasp in math class. I love it. I love it.
That's like something I would do.
You know what, guys? Just to make this a little bit easier for you, we're gonna do pi. Oh. We're gonna do this. That's never good when I do that. Let's do pi over 2 is 4 units. No, sorry, pi over 2, and I wrote 4 underneath. Pi over 2. And this will be pi.
That is exactly what we do, guys.
Was that what made you gasp? Okay. It's like I'm trying to math it out in my head so that it looks a little bit better. 1, 2, 3, 4. Okay, so put. Oh, did I mess that up? I did mess that up already. And I'm not using an erasable pen. Oh, this is terrible. Every fourth one, I screwed up on my first one. Every fourth one, go pi over 2. I'll get caught up to you in 2 seconds. Every fourth one. So 1, 2, 3. Oh, it was right. 1, 2, 3, 4. It was right. Pi over 2. 1, 2, 3, 4. Pi. 1, 2, 3, 4. 3 pi over 2. 1, 2, 3, 4. 2 pi. Okay, I was right. I obviously, counting is harder than it looks, everybody. Nice thing is the y-axis will go up 4s, just so it looks like a nice graph. Holy Hannah. Why am I scaring you? I'm scared too. What am I doing? I'm scanning. Why? You're calling me a scammer. What for? This is the guy who I just watched sleep for the last 5 minutes. And that's okay. If it's not right for you, that's okay. Okay. Does everybody's coast graph look like that? Yes? I'm so proud of you guys. All right.
What? You didn't know you graphic? No, can't.
Okay, so the 4 is in front of the x's. So you said that we are going to times our x's by a factor of 1/4. What are we touching this time? We're touching the angles. Woo! Super Okay, I'm gonna just slide this off for a second. Oh, look at this. We were doing perfect squares in grade 9. Oh, can we go back and do that? All right, so.
I wish, man. Area and parameter were so easy.
Was it easy when you were doing it?
It was so easy, man. I was locked in.
Okay, you guys agree that's your original table, right? So we're going to take every x value and we're going to times it by 1/4. So our new table of values, anything happening to my y's? No. Nothing's happening to my y's. What is 0 times by 1/4? Hopefully still 0. What is pi over 2 times by 1/4?
Pi over 4.
Try again.
Wait, it's pi over 4.
Okay, we're gonna go here. Pi over 2 times by 1/4.
Oh,
Pi over 8. It did, but that's okay. Sometimes our brains need to kick into high gear. Pi times by 1/4.
It's pi over 2. Wait. I'm doing slow, bro. Observing.
Okay, maybe we should write this one down. 3 pi over 2 times by 1/4.
8. 3 pi over 8.
Okay, there you go.
2 pi times by 1/4. As a reduced fraction, everybody.
1 pi over 2.
Brilliant.
Yeah. It's pi over 2.
Okay.
Whew. Guys, and I would suggest that if you don't feel comfortable, do this math on a scrap piece of paper. And the reason why I say scrap piece of paper is sometimes it just gets a little cumbersome when you start having all these things happening around the table of values you need to graph. Would you guys agree that this is a full period? Is this a full period? Started at a max, showed you the min, gone back to the max. That's a full period. 2 pi is a full period. You know this about cosine. Now we're going to graph that graph. Where's pi over 8? So this one here would be pi over 4 because it's halfway. So pi over 8 would be each tick. Each tick is a pi over 8. This still starts at 0, 1. Then I'm going to pi over 8 at 0. Where do I go next? Pi over 4, which is -1. And then what do we got? 3/8, so that's 1, 2, 3. So I'm back to a median here. And then at pi over 2, I'm back to a maximum. How do you feel about that? Emotionally distraught? A little bit? Are your arrows pointing the right way, ladies and gentlemen? Are they all pointing down? Okay, great. Let us do the next one by a factor of 2. So what am I doing to all of these? Timesing it by 2. So what would that look like? This would be 0. This would be pi. That would be 2 pi. 3 pi over 2 is going to be, okay, don't all show it at once. 3 pi. 4 pi. Isn't that beautiful? That's nice. Aren't those great? Okay. Now this one I'm off the graph. So my arrow's pointing up on this one. Do I show a full period on this last graph that I graphed? No, because I show a max, I show a min, but I don't show us getting back to the other max. Okay. Before we've got 1 minute left, so I'm going to take my minute. To determine the period, take 2 pi and divide it by the b value. And the reason why we put absolute values around that is you don't want, the period's not positive or negative, it's just a distance of time. So the b value comes from your formula. Make sense to everybody? Sorta, kinda? Okay. Hey, can we do the period for this guy right here? What was the b value? What was the b value in the equation? We did. It's a 4. Okay? So if we're finding the period of the red graph, we're going to take, so period is equal to 2 pi over b, 2 pi over 4. So I know that my period is pi over 2. And if we look at that, it hits a max to a max at pi over 2. Are you back in? You know what's going on?
Yes.
Look at that.